Again, the temptation is probably to expand these out, combine your like terms, and then factor the result, which also will lead to the correct answer. But anytime you can find a form, if you recognize that you have something in a given pattern, and look to see if you can apply it and simplify your solution. So here we have one quantity being squared. So the base is x squared plus 1, but we're squaring it, minus, can we express this second term as a squared value? Yeah, 4x squared is what base squared? 2x. So we have this pattern of a squared minus b squared. It is the difference of squares. So we can factor that into the pattern a plus b minus, or times a minus b. And then all we need to do is figure a is this whole expression, x squared plus 1, and b is the base 2x. So plus 2x minus 2x. So when we're looking at these here, same idea. You have a factor whose polynomial or whose degree is something greater than 1. So let's see if this factors any further. In order to do that, we do want to rearrange these each of these these polynomial factors into standard form. So x squared plus 2x plus 1 and x squared minus 2x plus 1. So let's factor these. We have binomial factors, the leading coefficient of these of this first factor. And you can do it one of two ways. You can either find what two factors of positive 1 have a sum of positive 2, plus 1 and plus 1. You could also recognize this is a perfect square trinomial, so it's the base x plus 1, or the quantity squared. Do the same thing here. It fits the same pattern. You can either reverse FOIL two factors of positive 1 whose sum is negative 2, negative 1, and negative 1, and that's going to give you your factors. You can write them this way. I don't know if I have it set to where it'll accept this as well, but you could also express this in this form.